So hello students, welcome once again. See, today we are going to take up the practice sheet for advanced upcoming advanced exam on the chapter complex numbers. See, today I am recording this video on laptop, so bear with me because of some problem on board and some technical issues. Okay, so let's start with the questions. I believe that you people would have tried to solve these questions, which you would have got as PDF on the post. So let's start with the first question here itself. The first question is, if mod of z is 1. Okay, so what does that mean? So first of all, we should know, or we should be using whatever we have given, or we should try to comprehend whatever information is being given to us. So mod of z is equal to 1 means all possible complex numbers, so all possible z which lie on the circle. So which lie on the circle whose center is, origin 0 comma 0 and radius is 1. So units radii circle, unit radius circle with center at the origin. I think all of us know it. Okay, if anyone is having any doubt, then let me tell you that we compare it from this equation, which is the standard form of the equation of a circle on the argand plane, on the complex plane. Isn't that? I think all of us know it again. So that's the standard form of the equation of circle on the argand plane, where z naught is the center of the circle and r is of course the radius of the circle. So that's one information which is very clearly visible from here. Now then prove that the points so I see, I'm not saying that we are going to use it, but looking at this statement, the first thing that should strike our mind is that okay, all those that which satisfy this equation lie on a circle of radius 1. Okay, now prove that the points represented by, so I will say let omega be a point which is nothing but under root of 1 plus z upon 1 minus z, lie on one or other of two fixed perpendicular straight lines. Okay, so they lie on one or the other of two fixed perpendicular straight lines. So I will say, since we have to find locus, so it's x plus iota y. So we have to find locus of omega, not z. See, z locus is given to us. It's on a circle with a unit radius. Okay, now omega is x plus iota y. Now let us try to take it look at it. So if I see squaring, if I square both the sides, so omega square is nothing but 1 plus z over 1 minus z. So I can write it as minus z minus 1 over z minus 1. Isn't that? Now see, I'm going to use rotation here. Why? Because as all of you must be knowing, it's a standard form of rotation which says like z1 minus z2 over z3 minus z2. So how do we look at it on the argand plane geometry? We geometrically we look at it as like rotating z3 about z2 by some angle theta, by some angle theta to get, okay, so by some angle theta to get z1 about z2. So see, the biggest hint bacho for the use of rotation is the presence of common complex number with the same sign in both numerator and denominator. And of course, to compare it with this form, we ensure that the sign with the common complex number is negative minus 1 on in both numerator and denominator. So what does that mean? That means we are going to rotate z about 1 to get minus z. Okay, so rotating z about 1 to get minus z. Now we know, okay, so we know that it lie on a circle of radius 1, center 0. So that's some, this is some type something like this. Okay, just a minute, bacho. So of course, yeah. So where's minus 1 here, bacho? So minus 1 is here. Now z and see, if this is z here, then minus z will be its diagonally opposite, diametrically opposite somewhere here. Okay. Now rotate z about minus 1 to get minus z. So to get minus z. So again, see, the line segment joining minus z and z is what? Is nothing but diameter. So what's the angle of rotation in that case? So we know it's nothing but 90 degree. So angle of rotation, so when we rotate z about minus 1 to get minus z about minus 1, angle of rotation, how much is it? Is pi by 2 or minus pi by 2, plus minus pi by 2. Okay. Now what does that mean? See, argument of omega square is either pi by 2 or minus pi by 2. I think all of you will agree. But what is omega square in that case? Okay, so since we need locus, and I said omega is nothing but x plus iota y. So argument of x square minus y square plus 2 iota xy is equal to plus minus pi by 2. So see what's happening. Whose argument, and on the argand plane, which complex number is it whose argument is plus pi by 2 or minus pi by 2? So how do we define argument? Argument is nothing but the angle which the line segment joining O to Z, the directed line segment, makes with the positive direction of the real axis. Okay, so if argument is pi by 2 or minus pi by 2, in any case Z has to lie on the imaginary axis. That means it's the real part. So what's the real part? Real part is x square minus y square has to be 0. So what do we get? So isn't it a pair of straight line, pair of perpendicular straight line? Okay, so Z lie either on the line y is equal to x or on the line y is equal to minus x. So one of these two lines. So that's it. So that was the question which I tried to solve with the help of geometry and algebra both. Okay, so I applied both the things here. Okay, so that's the first question. Now moving to the next one. Next one here, I think in PDF form you would have got the correct one. There's a small, yeah, uh, correction here. Now see, we have to find locus of z. Okay, now this is what? This is distance of z. So if I say z is equal to x plus iota y, see, first I try to use the geometry or then algebra. Okay, so I'm keeping my both the side open. See, for geometry I don't need to normally assume z is equal to x plus iota y. For algebra we do it. Okay, so I'm keeping that side also open. So this thing is nothing but distance of z from 2 plus iota. Okay, so this is nothing but distance of a variable complex number z from a fixed point 2 comma 1 on the argand plane. Now this is given to be mod of z. Let's keep it. Acha, mod of z into, let's simplify it. So okay, so for that case I will, since argument z is a variable complex number, so hence theta is also a variable here. Okay, so theta is also a variable here. So this will be into sine of, so I assumed it to be theta minus theta. So what is it? So mod of z into 1 by root 2 cos theta minus 1 by root 2 sine theta, and we have mod here also. So we have mod here also. So now what is it? Okay, okay, so distance of z from the fixed point 2 plus iota. See, let's say mod of z is r. Okay, so mod of z minus 2 plus iota is equal to, mod of z is r. So 1 by root 2. See, this is also mod and this is also mod. So I'm taking mod z inside here. So it's r cos theta minus r sine theta. Now, right, we got it. So r cos theta plus iota r sine theta, polar form of representation. And if I write it in the algebraic or standard form of notation for complex number, so of course x is r cos theta. So this is mod of x minus y by root 2. What is it? This is nothing but distance of a variable point x comma y from the line x minus y equal to 0. I think all of you will agree. And left hand side is the distance of a variable point z, of course, which is being represented as x comma y on the argand plane from the fixed point 2 comma 1. So what's going to be the locus? So now all of us know it, isn't that? So the locus is nothing but the parabola. So that's the answer. Okay, so again, see, I didn't disturb this part. Okay, see, the point is, if we just open it uh, completely, it might get complex. Okay, so since it was clearly visible what is it representing, so if required I would have opened it later. Okay, but it was clearly visible geometrically what does it represent, but on the right side, to me at least, it was not clearly visible geometrically, so I tried to apply algebra. So a mix of both the things, we got the answer. So moving to the next question, which is this: locus of z if argument of z minus 1 plus iota. So again, see, if argument of z minus z1 is equal to theta, what does it normally represent? It normally represents part of a straight line. It's not a complete straight line, isn't that? So part of a straight line passing through the fixed point z1 and inclined at an angle theta with the positive direction of real axis. How? See, if this is our real axis, and of course this is our imaginary axis, and this is point z1 here. Okay, so what does it represent? So Z, and this is Z1, and that's any point here on this line Z. See, again, argument of Z, as I said earlier, argument of Z is theta. What does that mean? That means that angle which it makes. I think we discussed it, no? Just a few slides back. So the angle which it makes with the real axis, positive direction of real axis, okay, the line segment joining from O to Z. So actually this is argument of Z minus 0, O, origin is representing the complex number 0. So if we have instead of 0 argument of Z minus Z1, so that means instead of 0 you'll be using Z1 here. So okay, now draw a horizontal line passing to Z1, and then argument of Z minus Z1 means from Z1 towards Z, the directed line segment from Z1 towards Z, the angle which it makes with the positive direction of real axis, or any line, horizontal line passing through Z1 is parallel to the positive, parallel to the real axis. Okay, so that's your argument here. So argument of Z minus Z naught is equal to theta, let's say theta 1. So that's your theta 1 here. But okay, so that's the logic we'll be using here. So argument of Z minus 1 plus iota. Okay, so let me just draw it. So 1 comma 1 is somewhere here, let's say. Okay, so I'm drawing a horizontal line passing through it. Okay, now argument of z from z minus 1 plus iota is 3 pi by 4. It's an obtuse angle. Okay, so that means of course this is z1 over z1 1 plus iota, and argument is positive, so that means we are rotating in anti-clockwise direction. So that's your 3 pi by 4. Okay, so that is when, but there's a condition. When mod of z is less than equal to mod of z minus 2. So mod z is equal to mod of z minus 2. Now what does that represent? See, again, geometrically, if we go for geometry here, mod of z is nothing but distance of z from origin. Mod of z minus 2 is nothing but distance of z from 2. And if they are equal, so we will get the equation of perpendicular bisector of the line segment joining Z, and of the line segment joining 2 and origin 0 here, bacho. Okay, so just a minute. Uh, there's some problem here. Yeah, we got it. Yeah. Okay, so of the perpendicular bisector of the line segment joining 0 and 2 here, so Z should lie here. Now what? If mod of Z is less than, see, I always say if you have to analyze the inequality geometrically, you should analyze first the corresponding equality. Okay, so we know if the equality has to hold, Z lie on the angle perpendicular bisector. If mod of Z is less than this, of course, inequality means on either side of this line. So which side, now we can easily decide. Mod Z is less than mod of Z minus 2. Of course, Z has to be on the left side. So Z lie on any, on the left side of this line. Okay. Now, this is 1 comma 1 here. See, if it will intersect, since the slope is same, this will be actually 2 comma 0. Okay. So that's the line. So uh, so that means, see, in any case, the line is on the left side of it was already on the, this ray was on the left side of this perpendicular bisector, so it holds. Okay. Now the second one is minus pi by 4. So argument is minus pi by 4. Argument is negative, means we have to rotate in clockwise direction. So clockwise direction, this is 3 pi by 4. This has to be pi by 4. So angle is minus pi by 4. But then the condition one is when mod of z is greater than mod of z minus 2. Okay, so mod of z is greater than mod of z minus 2. Okay, fair enough. So that means, right, in that case, if mod of z is greater than mod of z minus 2, the region is on the right side. So this represents the region, of course, on the right side of this line. So I think so, nothing. going, so this should represent this line. Okay, so actually this represents the entire line except the point, this except the point 1 comma. See, let's see what's the straight line passing through 2 comma 0. Straight lines, no, passing through 2 comma 0 and 1 comma 1, a line segment, a set of two rays, a straight line, straight lines passing, no, lines only, if even if it had been line here, so 2 comma 0 and 1 comma 1, um, what, a set of two rays, I think will be the best, closest answer here, isn't that, bacho? You know, because see, the point is, on this side, z has to lie on the, this part, the red part of the straight line, and on the other side it has to lie on the yellow part of the straight line, except the point 1 comma 1. 1 comma 1 cannot satisfy, and the given equation at any case, so I think D option should be the correct answer. Anyways, we got the line, we got, geometrically whatever we needed. So I mean, ठीक है, there might be some confusion regarding the option, might not have been well framed or whatever it is, but ठीक है, I think you people would have got the idea how to evaluate it. Okay, so that was the idea behind the question. Now, Z be a complex number and A be a real parameter such that this happen. Now, looking at it, what the first thing that strike our mind? See, the first thing that should strike our mind is z cube minus a cube is equal to 0. So z minus a into z square plus a square plus az equal to 0. So z is a complex number. So I'm assuming, since this is not given, so I'm just rejecting it. But see, what are the roots? So z cube minus 1 equal to 0. The roots are z is equal to 1, omega and omega square. Okay, so that means here in this case, the roots will be z is equal to a has already been removed. Z is equal to a omega and a omega square. A is the parameter. Of course, omega is a fixed number. Okay, and mod of omega we always know is 1. It's a cube root of unity, isn't that? So mod of z is mod of a. So this option is directly visible and correct. Okay, and argument of z is plus minus 2 pi by 3. Locus of z is a circle. No, it's not possible, because a is a parameter, is not a fixed constant. Locus of z is a pair of straight line. Yeah, that's fine. That's fine. Why? Because see, if you go for argument of z, so it's nothing but argument of a plus argument of omega. Now, a is a real parameter, so either is positive or negative in any case. You see, bacho, in any case, this is going to be a number, a fixed number. Okay, so either it's pi plus, pi by 2 pi by 3, or it's maybe 0 plus 2 pi by 3. Okay, positive or negative depending on that. So in any case, argument of z is fixed, isn't that? So 2 pi by 3, that argument is fixed. And similarly, argument of z, if I assume a to be positive, and so argument of z is either 2 pi by 3, or argument of z is either 4 pi by 3. So one line should be this one, and another line should be minus 4. Argument of z is 4 pi by 3, something like this. Is a pair of straight lines. So that seems to be the correct one, and this is obviously the correct one. Argument of z is plus minus 2 pi by 3. Yeah. Um, yeah, that should also be the correct one. Okay, because 4 pi by 3 is nothing but 2 minus 2 pi by 3. So A, C, and D should be the correct answer here, bacho. Okay, so circle can't be a possibility. Locus of Z is a pair of straight line is fairly close, an option, isn't that? Okay, so that's it. Rather, it will be. Yeah, no, for sure. See, A is a real parameter. If it's positive, it's 2 pi by 3. If it's negative, pi plus 2 pi by 3. So in any case, you will get both the signs. So for this argument is 2 pi by 3. For this part, it is pi plus 2 pi by 3. Isn't that? Similarly, yeah, it should be. So the answer should be A, C, and D. That's it. Now moving to the fifth one, which says the question is, if from a point P representing the complex number z1 on the curve. So see, again, see, just by looking at it, what we know, it's the z lie on the circle whose radius is 2 and center is origin. Pair of tangents are drawn to the curve. Another circle, center at origin, radius 1, meeting at the point q, z2 and z3. Then complex number does that. See, first let us try to draw a appropriate figure here. So 1 is a circle of radius 2 unit. See, I'm not that good in using the tools here. Okay, so sometimes it take auto correction. Okay, but I don't know when it takes and when it doesn't take. Anyways, P is a point here on the outer curve. Tangents are drawn outer circle to the inner circle to meet the circle at Q and uh, array Q and R. So it's Z2 here, it's R Z3 here, right? Okay, so I suppose it's Z1 here. Yeah, it's Z1 here. Now, okay, so now see what do we know about this circle primarily? I mean this figure. So this is of course 2 unit, OP is 2 unit. Okay, and what else? Of course, these two are equal. Fine. So let's see what have they asked here. So complex number will lie. Okay, that means first question is that the what is the centroid of the triangle? Isn't that PQR lie on the inner circle? Chaliye, let's try to prove it. We need to prove it. Check it actually. Okay, so what do we know? Other things which we know here is of mm, this is right angle. This is 1. This is 2. So this is root 3. Okay. If this is root 3, so in this right angle triangle, if this angle is theta, so tan theta is equal to 1 by root 3. So this is 30 degrees. So in any case, this is also 30 degrees. This is 60. And two adjacent sides are equal. So that's an equilateral triangle. So triangle PQR is an equilateral triangle. That's the first thing we proved here. Okay, so one thing is that it's an equilateral triangle. Just a minute. So let me just clean this figure here. Angle, I think we have already used. Fine. Side length, we already remember. We will remember. Okay, so this is nothing but root 3. Fair enough. Now what, bacho? Let's see. Okay, so okay, can we find this length? Let's try it out. So this is 90, this is 60, so this is also 30. Okay, and hypotenuse of this right angle triangle, if I call this point M, what am I talking about is triangle OMQ, right angle, that M. Okay, so this is what I need here is OM, bacho. So what shall I use? I shall use it as sine 30, isn't that? So sine 30 is half, which is OM by 1. So OM is half. Okay. So this point, see, why am I doing it? Let me, I will tell you, just let me complete it. So this imply OM is half. So that means MN is also half. I think we got it. Okay, so now, and NP is 1. So that means ratio. So Mn is to Np is equal to 1 is to 2 is to 1. Okay, so that's it. And see one thing. Uh, this has to be the perpendicular bisector of the segment QR. That very easily you people can prove for sure. Okay, now see what's happening is, so we know that the centroid divides, and this perpendicular bisector is an equilateral triangle. It has to be the median. So centroid is definitely going to lie on it. Okay, so centroid divides the median in the ratio 2 is to 1 from the vertex side. So n point divides PM 2 is to 1 on the vertex side, and is the median. PM is the median. So of course n is the centroid. So first option is correct, that centroid lie on the inner circle. Now second option is 4 by mod z bar. See, for such a situation I always prefer to go for this. Okay, multiply and divide by z1 in the first term, and then second term z2, so it's mod of z2 whole square, z2 into z2 bar. Third term z3 by mod z3 whole square. Okay, And then similarly in the second one, 4 by z1, I will be multiplying and dividing by the bar, the conjugate. Okay, so again it's mod z1 whole square. Similarly, it's z2 bar by mod z2 whole square plus z3 bar by mod z3 whole square. Now what is it? So how much, what is the value which I am going to get here? So mod z1 whole square is nothing but 4. So 4 gets cancelled. So actually it is z1 plus z2 plus z3 into z1 bar plus z2 bar plus z3 bar, isn't that? Now we know that mod of z1 plus z2 plus z3 by 3 is nothing but 1. By why? Because this point lie on this circle. Okay, so any point satisfying lying on the circle will have need to have its modulus as 1, isn't that? So what does that mean? So we know modulus gets distributed over product and ratio, so this is nothing but 3. So if I take and see, this is nothing but z into z bar, isn't that? So mod z whole square, so which is mod of z1 plus z2 plus z3 whole square, which is 9. So that's 9. So B option is also correct. Argument of z2 by z3 is 2 pi by 3. So where is z2? Z2 by z3. Okay, fine. See, argument of, we have already discussed that rotation thing. So I can write it as, so rotating Z3 about origin to get Z2 about origin. So if I rotate Z3 about origin to get z to about origin, the angle of rotation is anti-clockwise here, and the argument is 2 pi by 3. See, now you may say, of course, what if I would have taken z3 here and z2 here? The angle of rotation would have been clockwise. So in any case, see, argument of z2 by z3 is 2 pi by 3. So that's again an option. It can be 2 pi by 3, it can be minus 2 pi by 3. So I will consider it to be the correct one. Orthocenter and circumcenter of triangle PQR will coincide. Of course, it's an equilateral triangle PQR. So all the center, orthocenter, incenter, circumcenter, centroid, they are all the same point. Okay, so ABCD, all options are correct answer here. Okay. Now moving to the next question. Next one is, if z is a complex number lying in first quadrant such that x plus y. See, it's a very simple question, but I just picked it up for you because it you may be applying the complex, a bit of complex for just to get this. I mean, just to get this condition. Of course, using z is x plus iota y, and then you have to finally minimize or maximize. You have to get the maximum value of this one. Okay, so all of you us know what are we going to do. So this is nothing but f of x. To get its maximum value, you will differentiate it, and I think you will get x is equal to 2. Okay, so we all know the method. So derivative method, the first order derivative method. So which says f dash x is equal to 0, and then we get a critical point. I think x2 and 0. 0 is not a possibility because in that case the value will be 0. And since x and y are both positive, I mean they can't be non-negative. Okay, they are positive. So 0 is not a possibility in that case, and that can't be the maximum value. It has to be the minimum value. If it at all, it would have given us any value in that case. Okay, so that's a very simple question. Just selected it because it involves something there. Now, see, there's a correction here. I goes from greater than equal to 1, which is less than j, which is less than equal to 100, alpha I, alpha j raised power 5, and 100 roots of unity. So these are the 100 roots of unity. Okay, so 100 roots of unity means 1 alpha, alpha square, alpha cube, and so on and so on. Alpha raised to the power 99. See, we can have two different approaches to approach to solve this question. One is like alpha raised to the power 5. So alpha p raised to the power 5. So alpha p is a 100 root of unity. So cos 2p pi by 100 plus iota sine 2p pi by 100. Okay, raised to the power 5. Applying de Moivre's theorem, we know the power 5 will come inside and get multiplied with the argument. So it will be 2p pi by 20 plus iota sine 2p pi by 20. So what is it? So alpha p raised to the power 5 is nothing but the pth root or the 20th roots of unity. Okay, 20th roots of unity. Just you compare it with this form, because see, in general we know zk is the nth one of the nth root of unity, whose general form is 2k pi by n plus iota sine 2k pi by n. All of you agree, isn't that? Okay, so now when you take power raised to it to the power 5, it's 20th root of unity actually. Now, but 20th root of unity, if I write it now, see, 1 alpha squared dot alpha raised power 19. These are the 20 roots of unity. Now alpha raised power 20 is again 1. 21 is alpha squared, and alpha raised to the power 38. Okay. um 20, 39. Yeah, 39. Okay, so that will be alpha raised power 19 again. So similarly, alpha raised power 40 will be 1 alpha square, and then again alpha raised power 59 is 19, again alpha raised power 60. So we'll have five such set of. So okay, I think you people got it. So this is nothing but alpha raised power 20, alpha raised power 21. This is nothing but alpha raised to the power 39. This is alpha raised for 40, 40th roots of unity. We are going in the for roots of unity, 100 roots of unity, 59. Then 1 alpha, so this is alpha raised for 60, and so on and so on. Alpha raised for 99 will be the last one, which is alpha 19 again. Okay. Now see, when we are multiplying, so it's like taking two roots at a time. Okay, it's like simply taking two roots at a time. Now see what I will do. Let's say alpha I is 1. Start with the first one. So now you will be multiplying 1 with alpha plus 1 with alpha square plus dot dot dot. So I take one common to alpha plus alpha square dot 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 plus alpha raised to the power 99. All possible roots, isn't that? Now, but again, see, I'm not going in that case because I'm just talking roots of 20th roots of unity. Okay, wait. Okay, see, so I will say, so when we write it, so till alpha raised to the power 19. So take one common, so one alpha plus alpha square 19. I mean this thing, and then again plus 1 plus alpha square. But then this, see, this is all the sum of roots of unity. Isn't 20th roots of unity? If you add them, you get 0. So similarly, this will be 0, this will be 0, this will be 0, this will be 4 set will give you 0. And what are you left with? Only this thing. What are we left with is only this thing. Similarly, when you write for alpha, I mean, you take this and multiply them. Okay, so again, what will you get? Alpha square plus, because j is greater than I. So the first number which you will take as j is alpha square, alpha cube plus alpha raised power 19. And then plus alpha, multiply these all. So when you add them, 1 plus alpha 19, this is again 0. So again alpha times this is 0 0 0. So what do you get here is this one. Similarly, you go for alpha cube, and then for alpha cube for the rest of the four set, this will be 0, this will be 0, this will be 0. Okay, so what does that mean? See, ultimately what's happening is, what are we left in the first step? In the first step, what are we left are is the sum taken two at a time, like 1 into alpha, 1 into alpha square, 1 into alpha raised to power 19, alpha into alpha square, alpha into alpha cube. So taken two at a time, and we know sum of all the roots of unity taken two at a time, taken two at a time is 0. All of you agree? Why? Because see, roots of unity are actually roots of which equation? Are roots of z raised to the power n minus 1 equal to 0. Okay, so now if I write the sum of roots taken two at a time, so it's 0. Why? Because see, sum of all the roots taken for sum of all the roots minus b by a, b is 0, and then c by a, c is 0. There are only two coefficient, the leading coefficient a, which is 1, and the constant term, the last term. Okay, so in between, sum of roots taken three at a time is 0. So in any case, all the such combination is 0. Okay, now you may say, what about when we start with this? So you get the same thing, bachcho. You start with the next one. See, after alpha 19, you come to 1 here. So when you start it, so 1 into alpha square, and then alpha raised power 19, and then plus alpha. Okay, and then 1 into this all 0, this all 0, 0, 0, 0, and then alpha into this. So again, this will be sum of taken two at a time, sum of taken two at a time, it will be 0. So that's one approach which I thought initially. Okay, so it's a lengthy one, but it's okay, we get it. Now the other one is, see, if I assume alpha I raised to the power 5 is sum as maybe z1 alpha j zi alpha j raised to power 5 as zj, and if I see, what we need is taken two at a time. So that's a very I mean, for double summation, it's a, and when I is less than j, Okay, the best way of doing it is using the perfect square thing. So what is it? So z1 plus z2 plus z dot 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 z100 whole square minus z1 square plus z2 square plus dot 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 z100 whole square whole divided by 2. That's it. Now this is nothing but sum of all the roots of unity, which is 0. Um, isn't that? Wait. Or the 100 roots of unity. Yeah. So that is 0. And then this is z1 square plus z2 square plus z3 square. Um, uh-oh. So what will be the value here? Z1 square. Okay, right. I think that will also be 0. Why? See, z it's like 1 alpha square alpha raised to power 99. The sum is 0. So when you raise it, so 1 alpha square alpha 4. So what will that be? So you will again get GP. So it will be 1 plus alpha square plus alpha 4 plus dot 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 alpha raised to power 198. So it's alpha raised to the power. Um, how many terms are there? Alpha square is the common ratio raised to the power 100, right? There are 100 terms. Minus 1 upon alpha square minus 1 using the sum of GP. See, alpha raised to power 200 minus 1. And since alpha is a root of unity, so alpha satisfies the equation z is power 100 minus 1 equal 0. So alpha raised to power 100 is equal to 1. So alpha raised to power 200 is also 1. Hence, this is also 0. So this is also 0. This is also 0. So answer is actually 0 here. So that's another way of approaching this question. So okay, I think you all would have got it. So now moving to the next question here. Next question is, this is given and we have to find the range of this. So what I actually thought was mod of z plus 1 by z whole cube. So it is nothing but mod of z plus 1 by z cube, which is mod of um, z cube plus 1 by z cube plus 3 times z plus 1 by z. Okay, so uh, okay, we have to find a range. See, range 0 to, of course, C option is not an option, I think. What should I do in that case? Okay, so if I use this property that mod of z1 plus z2 is less than equal to mod of z1 plus mod of z2. Okay, so what will we get here? Let me try. So mod of z plus 1 by z whole cube is equal to mod of z cube plus 1 by z cube plus 3 times mod of z plus 1 by z. And we need its range. Okay, so let's say mod of z plus 1 by z be p. So p cube minus 3p is equal to mod of z cube. Oh, no, this is less than equal to. I'm sorry. Isn't that? So it's not an equality here, but just a minute. It won't be an equality here. So of course I use this property. है ना? So right. So it will be p cube minus 3p is less than equal to 2. Mod of this, and this is, since this is less than equal to 2, so I will say this is actually less than equal to mod of z cube plus 1 by z cube, and this is less than equal to 2. So p cube minus 3p minus 2 is less than equal to 0, 0, 0, 0. So p is equal to 1. Let me try to solve this. See, we have to solve this inequality in this way. So minus 2 equal to 0. So p minus 1 is its factor, because p is equal to 1. Does it satisfy? No, it doesn't. P is equal to minus 1 satisfy. Yeah. So it's p square, and then p cube minus p square, so plus p square minus p, and then minus 2 is less than equal to 0. So p plus 1 into p minus 2 into p plus 1 is less than equal to 0. So p plus 1 whole square into p minus 2 is less than equal to 0. So of course p has to be less than equal to 2. That's it. Okay. Less than equal to 2. So that should be the answer. And of course, it has to be greater than 0. It can't be even equal to 0 because it is z plus 1 by z. We got it. Okay. So that's it. That was question number 8. And then moving to the next question, I think there's some problem in the numbering of the question. Chali, anyways. Z1, Z2 satisfy this equation. Okay. So first of all, let us try to get this equation 2 times. If I say, see, real part of z is of course x mod x, and then it is, so if I assume z is x plus iota y, so actually this is 2 times the distance of z from a fixed point. So if I write it here, so mod of z minus minus 3, the fixed point is minus 3, okay, is equal to real part of mod of real part of z is the distance of z from the real axis, from the, I think, imaginary axis, I'm sorry, from the imaginary axis. So distance from the fixed point, distance of z from fixed point minus 3 is half times its distance from the fixed line, which is the imaginary axis. So what does that mean? E, this is eccentricity is half. So it's an ellipse. It's an ellipse, okay, whose focus is minus 3 comma 0, whose focus is minus 3 comma 0. So that's an ellipse whose focus is minus 3 comma 0. Okay, so, and since directrix is this, the imaginary axis, the fixed line, so of course the major axis will be the real axis, x-axis, so it will be something like this. Okay, so that's being the focus. So I mean, that's not the center. Okay, remember that that's not the center, though we can easily find it. So that might be the center. This might be another focus. This is one focus minus 3 comma 0. This is one end of the major axis, and this is our directrix. Okay, this is our y-axis, or imaginary axis is the directrix here. And argument of this, so writing this argument, see that simple argument of z plus 3 minus argument of iota plus 1 is equal to pi by 2, iota plus 1 argument is pi by 4, so argument of z plus 3 is equal to 3 pi by 4. Okay, so again that represents equation of a line passing through minus 3 z, argument of z, so fixed point is minus 3, and this is it. Okay, so this is it. So this is our 3 pi by 4 here, and that's it. Okay, and okay, Z1 and Z2 satisfy. So see, Z1 and Z2 to satisfy, it has to be like this. Then only it will satisfy. These are the 2 points. So let's see what have they asked. They've asked the value of Z1 plus C. So again, that's a rotation form. So it's argument of, so just a minute, let me use another color here. Argument of Z2 minus of minus 3. Rotate Z2 about minus 3 to get Z1 about minus 3. And since that's a straight line, okay, rotation about the same point through which the line is passing, so our angle of rotation has to be pi or minus pi, and that's an option, so that should be the answer. See, if I just assume this as the part, okay, so it will give you a ray only, a ray that passes through minus 3 and goes in this direction. Okay, let me just analyze for a minute. Can we get the other part also in that case? I don't think, because argument of I plus 1 is fixed, isn't that? We don't have a choice. Yeah, but then, so answer could be either none of this, because, but none of these doesn't make sense. Why? Because they have given Z1 and Z2 satisfy this equation. So, if anyone has any suggestion to get it, for me, I think there might be some problem here. It could be plus minus pi by 2. Then I think it would have given us the answer. Wait, yeah, I think that it would have given us the answer, because plus minus pi by 2 would have given this as minus pi by 4 and 3 pi by 4. Okay, so that's it. Now moving to the next one. Now see, look at this. So doesn't that match? If you see, mod of z1, mod of z2, mod z3 are all real numbers. So a cube plus b cube plus c cube minus 3abc equal to 0. Now what does that mean? Either a plus b plus c is 0, or a square plus b square plus c square minus ab minus bc minus ac is 0. All of you agree or not, bachcho? Okay, but since a is nothing but mod of z1 plus mod of z2 plus mod of z3 is equal to 0, doesn't make a sense unless all of them get 0. Not possible at all. So the only thing possible is this. And see, this is a very common expression, bachcho, which is actually a minus b whole square plus b minus c whole square plus c minus a whole square. And all of you must know it if you don't know it still. Okay, so that's it. So this is equal to 0 means a is equal to b is equal to c. So that means mod z1 is equal to mod z2 is equal to mod z3. So all of them lie on a circle of radius. Let's say p unit. I mean, radius is not fixed, but that's, I mean, radius is not given, but it's fixed. Okay, radius p and center at z origin. So they all lie on a circle with center at origin and radius p. That's it. Okay, now let's move to the question. So the given information tells us that z1, z2, z3 lie on a circle of radius p unit and center at origin. Now, maximum area of the triangle form. See, whenever you have a triangle inscribed in a circle, okay, the maximum area will be when it's an equilateral triangle. When it's an equilateral triangle, A, Z1, B, Z2, C, Z3. Now join this. And it's an equilateral triangle, of course. This has to be 30 degree. And then this is P unit. Okay, so this will be sine 30 p by 2, and this will be root 3 p by 2. Okay, so half base into height. Half base is root 3 p and height is 3 p by 2. So it's 3 root 3 p square by 4. That's it. That's what is given. Ortho center of the triangle formed by this. See, uh, ortho center of any triangle. See, maximum area for maximum. Okay, I was really going to commit a mistake here. So see, consider any triangle now, because for maximum area it need to be an equilateral triangle. So if I say this is B, this is C, now see, the circumcenter is fixed. So ortho center, let's say this is the ortho center, and G centroid is Z1 plus Z2 plus Z3 by 3, and circumcenter is origin. Okay, so that's our circumcenter of the triangle. Okay, because circumcircle has its center at origin. Now we know that G divides the orthocenter and the line segment joining circumcenter. The ratio 2 is to 1. So, so what does that mean? So Z1 by 3, I mean, applying section formula is nothing but G. So Z1 plus Z2 plus Z3 by 3. So orthocenter is Z1 plus Z2 plus Z3. That's again a correct option. If Z1 plus Z2 plus Z3 is an orthocenter triangle formed by, of course, that's it. That's correct. 2 times argument of Z3 minus Z1 upon Z2 minus Z1. So rotate about Z1. Okay, rotate. So this is, let's say, Z2. This is, let's say, Z3. Okay, so again, this is rotation form, but no direct rotation form. So rotate about Z2 about Z1. So rotate is where Z2, rotate Z2 about Z1 to get Z3 here. To get Z3 here. So this is the angle of rotation, let's say. Okay, this is the angle of rotation. Now twice of it, okay, is equal to Z2 by Z3. Z2 by Z3 means argument of Z2 by Z3 means rotation about origin. See, right. It's not necessary. And moreover, here we were rotating Z2 and here we are rotating Z3. Okay, first of all, the angle of rotation won't match, the sign won't match. And second thing is that might be possible only when it's an obtuse, it's an acute angle triangle. See, there's a property which says that, uh, just a minute, Bacho. I need to put it on charging. Yeah. So the point is, in an acute angle triangle, okay, so if I just draw something like this, let's say this is Z3, Z1, Z2. So angle subtended by the arc, the chord joining Z2 and Z3 and at the center. So if this is theta, this is 2 theta. So twice of this angle is this. But the problem here is, here in this case, we are rotating Z2. Okay. So rotating Z2 means the angle, the direction of rotation is, let's say here in this case, anti-clockwise. But when you rotate in the second one, Z3, because Z3 in denominator, Z3 about origin, first of all, the direction is changing. So there must be of opposite sign. Second, even if I ignore the sign, even if I ignore the sign, it's not for sure that it's an acute angle. It might be an obtuse angle also. Okay. So I think according to me, first three options must be the correct one, bachcho. Now moving to the next one. Next question is Z1, Z2, Z100 are roots of this equation. Okay, now what is it? So if you equate it, I mean, if you use it's GP, isn't that? So if you use formula for GP, so it's Z is for 101 terms, minus 1 upon Z minus 1 equal to 0. So actually the roots are the roots of this equal to 0. But when then you will say these are just 100 roots. It's a 101 degree equation. And of course, look at this. Isn't that a 100-degree equation? The degree of this equation is 100. Okay, so it has 100 roots, but it has one extra root, which is Z is equal to 1. So Z is equal to 1 is not the root here. So the roots are 1, alpha, alpha square, alpha cube, alpha raised power 100. Now these are the roots which we are going to relate here. Z1, Z2, Z100. Isn't that? Now how will I proceed? For Z100, 1 minus 1, or maybe let's start with this one, 1 plus z square. See, now we know which 100 roots are the roots of this equation. So so the roots are alpha, alpha square. So once we know the roots, won't we know the factors? Of course we can write it in this form: z minus alpha, z minus alpha square, z minus alpha cube, and so on and so on, z minus alpha raised power 100. So I just wrote it in terms of the factors here, bachcho. Okay. Now what? See why? Because we need it in this form, zp minus 1. Okay. So if I replace, acha, one more thing. These are 100 factors. So if I write it, I mean, if I just take minus 1 common from all of them, we get the same thing. So it's z1 minus z, z2 minus z, z3 minus z, and then z100 minus z. Isn't that? Now see, since I need it, what will I do? I will take log both the sides. So ln of 1 plus z square plus dot 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 z is for 100 is equal to ln of alpha minus z, alpha square minus z, ln of alpha 100 minus z. Now differentiating both the sides. Just differentiate. See, you will come to know why are we doing it. So 1 plus z square. See, that will help us to give whatever we need. So it in numerator it will be 1 plus 2z plus 3z square plus 100 z is for 99 is equal to, now see, minus 1 upon alpha minus z. Okay, okay. See, to get what I need here, I should have used this form only. But in that case also, I would have got 1 upon z minus alpha. No, no. In any case, you'll get the same thing. Wait. So it will be minus 1 upon alpha square z2 minus z, and so on, minus 1 upon z100 alpha 100 minus z. Now put z is equal to 1. So when you put it, so it's 1 plus 2 plus 3 dot 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 100 upon 101 is equal to minus, I'm taking common, 1 upon z1 minus 1 plus 1 upon z2 minus 1, and that's what we need. z100 minus 1. So that's what we need. Okay, so that's the series here. So what will be the answer? The answer is, so this is nothing but 101 n into n plus 1 by 2 minus sign. So that's the series. So this is nothing but minus 50. So according to me, the answer is minus 50. That's it. Moving to the next one. So you see, this is the question which I selected just for the uh, geometrical aspect, because see, mod of z again, mod of z minus 25 iota is less than. So as I always say, if you have to analyze the inequality, analyze the equality, corresponding equality, what is it? That's a circle with center at 25 iota and radius as 15, something like this. That's the circle. Okay, so this point is 0 comma 25 and the radius is 15. Now z is either less than equal to, means either z is on the circle or inside the circle. I think all of you will agree to it. Why? Because the distance of z from 25 iota is equal to 15 gives us a circle. So if the distance is less than 15, then it will give us the reason inside the circle, isn't that? Now find z with maximum and minimum argument. What is the argument? Argument is like, if z is here, then you join O origin with Z, the angle which it makes with the positive direction of real axis is the argument, isn't that? So for maximum and minimum argument, what are we going to have? So for maximum and minimum argument, if I draw tangents passing through origin to the circle where it touches, this one where it touches will give you the minimum argument. So this angle is the minimum argument of Z satisfying this given condition, and for maximum it will be touching it on the other side, so that will be for, so this will give us the maximum argument. I think all of you will agree. So the only thing is we have to find the minimum. Since it is I mean a symmetrical, the curve is symmetrical about the y-axis. So if I find z here, so it will should be its mirror image. So how to get z? So just join it. So it's a right angle triangle. So this length, origin distance to the center is 25 unit. This is 15. So O, and I call it Z1. So OZ1 is nothing but 20 using Pythagoras theorem. Okay. Now if I say that this angle is, let's say theta. Okay, so this angle is, let's say, theta. So let me use some other color here. Yeah, this angle is theta. Okay, so how much is this angle? So sine theta is 15 by 25 3 by 5. So cos theta is 4 by 5. So this angle is nothing but minus 90 minus theta. So for Z1, so Z1 is R cos sine theta. So R sine theta is 20 20 into 3 by 5 plus iota times R cos of sine of 91, which is cos theta. Okay, so 20 into 4 by 5, so it is nothing but 12 plus 16 iota. So if this is the complex number with minimum argument, then for maximum argument it will be 12 minus 16 iota, rather minus 12 plus, I'm sorry, plus 16 iota, as this is the mirror image that you can easily check. But okay, so that's it. So I just solved it using the geometry only, nothing else is required. Now that's an interesting one. Okay, so there's a purpose, because that's a special thing using which we can easily get this value. Okay, see, comparing it with this form again, alpha k is cos of, say, kth root of unity. Nth, I mean, the for one of the nth root of unity, the general form is this one. Okay, so n is 11 here for sure. But then you may say that here there's no 2 p pi, it's p pi. Yes, of course. But then there's a trick, and that trick is, if I consider 11 roots of unity quickly, 11 roots of unity. So what does that mean? Z11 minus 1 is equal to. So what are the roots? The roots are 1 alpha. I mean 1 z1. 1 is obviously the real root. So 1. So I will write it as z minus 1 into z minus z1. The first non-real root into z minus. We know the roots are exist in conjugate pair because it's a real equation. I mean, x raised by 11 minus 1 equal to 0. It's a real polynomial equation of degree 11. It has only one real root 1, so all 10 roots exist in conjugate pair. So the 10th, the last complex root, the 10th complex root Z10 will be its conjugate Z1 bar. Similarly, Z minus Z2 and then ninth Z9 will be its conjugate Z2 bar, and so on and so on. We'll have 5 such pair. Now, if I take Z1 this side, so again we can write it as 1 plus Z as a sum of 11 terms in a GP. So it's Z minus Z1. Okay. Now I'm just considering this as the first pair. So likewise we will have, I mean this is one pair. Likewise we will have two pair, three pair, four pair, five pair. Okay. So just analyze only one pair and we'll get what we need here. Multiply. So it's Z square minus Z plus Z1 plus Z1 bar plus Z1 into Z1 bar, which is mod Z1 whole square, which is 1, because we are talking about roots of unity. All roots have the same modulus, which is 1 here, isn't that? So now what are we going to get here is, so this is equal to, so see, yeah, Z square plus 1 minus Z times 2 times real part of Z1. That's it. Okay, now put Z is equal to 1. See, we have two choices here. One will go for cos and the one will go for pi for sure. Okay, so one will go for cos and the one will go for sine. I'm sorry. So put Z is equal to 1. So in LHS we get 11. In RHS it's 1 plus 1, 2 minus 2. And real part of Z1. Okay, so see, as I said, alpha k. Right? So it will be, let's say, ZK. So it would have been cos 2k pi by 11 roots of unity plus iota sine 2k pi by 11. So Z1. So the first one will be Z1 is cos 2 pi by 11 plus iota sine 2 pi by 11 here. Okay, that's it. So it is real part is cos 2 pi by 11. Okay, so it is cos 2 pi by 11. That's it. So they will have, and again 5 such pair. Okay, so what do we get? So it's 11. We take 2 common. 1 minus cos 2 theta minus 1 plus 2 sine square theta, and that's it. See, we got 1. So we got 2 square into sine square pi by 11. Another one will be 2 square into, I think all of you will understand, 2 pi by 11. Another one will be 2 square sine 3 pi by 11, 4 pi by 11, 5 pi by 11. So 2 raised to the power 10 pi sine k pi by 11. K goes from 1 to 5. That's it. And this is 11 here. So the answer is, and this is square. I'm sorry, this is square. Okay, so the answer is 11 by 2 raised power 10 is square root, and that's it. So P is root 11 by 2 raised power 5. As I said, see, coincidentally we got it in the first substitution. Z is equal to 1. If you put Z is equal to minus 1, what will be the difference? So if I put go for Z is equal to minus 1, what will you get here actually is, you will get it as 2 1 plus cos 2 pi by 11, and to get rid of 1 here, similarly we'll be using 2 1 plus 2 cos square pi by 11 minus 1. So it will be 2 square into cos square pi by 11. So if you would have been asked to get this series cos p pi by 11, so in that case p goes from 1 to 5, we would have gone for this as a substitution. That's it. Okay, so that was an interesting form. And the last one, see, see, I mean, I just selected it just because of one reason, and the reason is if I just take minus sign outside, so ZP is nothing cos of minus 2p pi by 10 plus iota sine minus 2p pi by 10. Okay, so if we compare it with the roots of unity form, which is cos 2 10 roots of unity, the same thing. The only difference you may say is of angle, because 2p pi by 10 is the angle here. So does it make any difference? Because see, the roots exist as conjugate pair as mirror image. So if this is the first root with angle theta, its mirror image will have the 10th root will have angle as minus theta. So the only thing is, now if I consider this as the 10 roots of unity, so I'll be counting this as Z1 and this will be Z10, Z2, Z9 will be Z9 earlier will be Z2, and the second root from the anti-clockwise will be the 9 2. The roots are the same, so it's nothing but 10 roots of unity where P goes from 1 to 9. Of course, P goes from 1 to 9, 10 roots of unity except 1. So everything is same. So Z is power 10 minus 1 has roots like Z minus 1 into Z minus Z1 into Z minus Z2, and the same thing we had been using it again and again, bachcho. Okay, so Z is power 10 minus 1 upon Z minus 1 is equal to Z minus Z1 into Z minus Z2 into so on and so on, Z minus Z9, taking modulus both the side. Okay, and what is it? See, we have already done it, so it's nothing but mod of 1 plus z square plus dot 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 z raised to the power 9. And then when you take modulus get distributed, z minus z1 into mod of z minus z2 and so on, z minus z9, put z is equal to 1, because that's what we need. So this is nothing but 10, and this is mod of 1, so 1 minus z1 into mod of 1 minus z2, and that's what we need, 1 minus z9 whole divided by 10. So the answer is nothing but 1. So the answer is 1 here. That's what we needed. Okay, now the second one. What is it? If P is from 0 to 1. See, if we go for sum of all the roots, Z1 plus Z2, Z9 plus 1. This is 0. Collect it real part and imaginary part. The real part is cos of 2p pi by 10. P goes from 0 to 9 plus iota times sine of 2p pi by 10. P goes from 0 to 9, and this is 0, and any complex number is 0 when it's both real part and imaginary part are 0. So this is nothing but 0, so this is 0, so answer is again 1 here, and that's it. Okay, so those were the questions selected for your like as a practice for your upcoming advanced paper, bacho. I believe you would have learned something and you would have got a good practice here. So chaliye, let's move. We will be taking up next chapter. Most likely it will be the sequence and series in our next session, bachcho. Okay, till then, bye bye. Have a nice